Mars and Its Canals by Percival Lowell. Chapter 18. The Double Canals, Part 3. Turning from such generic characteristics to more specific traits, the first thing to strike an attentive observer is that the doubles differ in width, that they are not mensurably alike in the property they hold in common of being paired. In some, the twin lines are obviously farther apart than in others, and the relation persists, however repeated the observations. Of two doubles, the one will always surpass its fellow. This contrasted individuality first struck me in the Phison and the Euphrates, and from the first moment at which these doubles showed as such. The Phison pair seemed perceptibly the narrower of the two. A like distinction was evident at the next opposition and the next, in fact, at every succeeding one to the present day. Nor was the recognition of the fact confined to me. If we turn to Schiaparelli's Memoriae, we shall find that the master had registered the same idiomatic width for the two canals from first to last throughout his long series of records. The observation thus made proved to apply to each and all of these curious twins. Diversity in width for different doubles appears plainly in drawings where more than one double is depicted. As an example, two drawings are here given in the text, made, the one on July 13th, 1905, lambda 15 degrees, and the other on July 20, lambda 313 degrees. In them, the Phison, Euphrates, Dijun, and Thoth appear contrasted as unmistakably as either of them does with the single canals apparent at the same time. That this drawing is typical is borne out by all the best measures of the several doubles as seen at successive oppositions, and marshalled in the subjoined text. How truly individual the quality is stands proved by the relative values in different years, which are even more accordant than the absolute ones. The canals were: width, Phison 1903 3.5, 1905 3.4, mean 3.4, Euphrates 1903 4.0, 1905 4.2, mean 4.1, Protonylus 1903 2.8, 1905 2.0, mean 2.4, Deuteronylus 1903 2.2, 1905 2.4, mean 2.3, Pierus 1903 2.5, Caliro 1903 2.5, 1905 2.1, mean 2.3, Hidakal 1903 3.8, 1905 4.9, mean 4.3, Gion 1903 3.9, 1905 4.9, mean 4.4, Jihun 1903 2.0, 1905 1.9, mean 1.9, Sitarchus 1903 3.8, 1905 3.3, mean 3.6, Jamuna 1903 4.5, Ganges 1903 5.0, 1905 5.2, mean 5.1, Nilocarus 1 and 2, 1903 11, 1905 11.7, mean 11.3, Nilocaras 1, 1903 2.3, Gigas 1903 3.5, Lystrigon 1903 2.2, Cerberus North 1903 4.0, Cerberus South 1903 4.0, Cyclops 1903 2.9, 1905 2.2, mean 2.6. Na 1903 2.6, 1905 2.0, mean 2.3. Fretum Anian 1903 2.8. Aethiops 1903 3.3. Eunostos 1903 2.8. Lethes 1903 2.9. Marcias 1903 3.2. Hyblaeus 1903 3.0. Amenethes 1903 3.2, 1905 3.5, mean 3.3. Thoth 1903 2.8, 1905 2.3, mean 2.5. Nepenthes 1903 2.8, 1905 2.3, mean 2.5. Triton 1903 2.7, 1905 2.3, mean 2.5. Pyramus 1903 2.9, 1905 2.0, mean 2.5. Astauborus South 1903 3.2, 1905 3.1, mean 3.1. Tithonius 1903 2.6, 1905 2.2, mean 2.4. Vexillum 1903 3.5, 1905 2.9, mean 3.2. Tartarus 1905 2.7. Here we have widths ranging from 11 degrees to 2. The widths given are those when the canal was at or sufficiently near its full strength, and are measured from the centres of the constituents. We notice 2 points: the agreement of the same canal with itself, and its systematic disagreement with others. But what is especially to the point, if we compare the values found at successive oppositions, we find that, for different canals, the values agree in their difference. This shows that each of these values is, in most cases if not all, a norm for that particular canal, a value distinctive of it, and to which it either absolutely or relatively conforms. In other words, the width of the gemination is a personal peculiarity of the particular canal, as much an idiosyncrasy of it at its position on the planet. 2 general classes may be distinguished: those up to about 5 degrees in width apart, and those above this figure. Whether such very widely separated lines as go to make up the second class, such as the Nilocharis 1 and 2, constitutes a double, is a debatable point. Schiaparelli thought they did, and so classed them. To me it did not at first occur so to consider them, and in some instances, such as the Helicon 1 and 2, later observations seem to justify the omission. With the Nilocharis 1 and 2, the outcome seems the other way. The reason for distrust of a physical relation between the constituents is not so much the distance separating them, nor any lack of parallelism, as the self-sufficient manner in which they show alone. Even this, however, tends to be recognized in the narrow pairs as they come to be better seen. It may be that width alone is wholly competent to selective showing. For the further apart 2 lines are on the planet, the more opportunity is afforded the airwaves to disclose the one without the other, a relative revelation which is constantly happening to detail in different parts of the disk. As long as any doubt exists of a physical community of interest, it seems best to distinguish such possibly merely parallel canals by suffixed numerals. Of this class of doubles is the Nilocharis 1 and 2. So wide is it that Mr. Lampland succeeded in photographing it as such, the 2 constituents showing well separated, and if it prove a true double, it will be the first Martian double to leave its impress on a sensitive plate. Although separated by 400 miles of territory, the two lines are parallel so far as observation can detect, which, of course, is not so very easy with the lines so far apart. In the country between one crosswise canal certainly lies the Phyrax, and much shading thus far unaccounted for. Recent discoveries, however, point to the cause of such shading as lines imperfectly seen, for in some cases the lines have actually disclosed themselves, and warrant us in believing that it is only imperfect seeing that keeps the others hid. Of the pair, the Nicholas one is itself double, curiously reproducing what sometimes is seen in the case of double stars, one of whose components turns out to be itself a binary. The second line of the Nilocaris 1 lies close to its primary on the north, and was, on the only occasion of its detection, the merest of gossamers, while the Nilocaris 1 itself stood out strong and dark. Thus do these Martian details increase and multiply in intricacy, the better the seeing brings them out. In the case of the other doubles, the doubles proper, so to speak, there is every indication of a physical bond between the pair. What that bond may be is another matter, and seems to be of different divulging, according to the particular instance. At one end of the subject, both as the widest of these doubles, and one of the most important, stands the Ganges. The components of the canal are 5.1 degrees apart. This great width, joined to the fact of scant extension, gives the canal a stocky aspect, its breadth being but 1/6 of its length. Its width draws attention to it, while the phenomena it exhibits intrigue curiosity. As early as the first opposition of my observations in 1894, the canal, as it underwent the process of doubling, showed phases of peculiarity. It was first caught by me as a double over toward the terminator, or fading edge of the disk. Then, as it was brought nearer the centre by gaining upon the longitudes, showed as a broad swathe of shading of a width apparently equal to any it later exhibited. In this appearance it continued for some months, and then, in October, began to show a clarification toward the centre. Once started, the lightening of its midway advanced till, at last, on November the 13th, it stood out an unmistakable double, the two lines standing where the edges of the swathe had previously been. Had the observations here been all that one could wish, the method of germination would have been certain and of great interest. Unfortunately, the observations left much to be desired, and those repeated in 1896 to 1897 and 1901 were of like doubtfulness. A period of swarthy confusion preceded the plainly dual state, but whether the double simply clarified or widened as well, it was not possible to assure oneself. That the canal exhibited plainly the effects of seasonal development was as unmistakable as the steps themselves were open to ambiguity. In 1903 the canal was at its minimum, and hardly to be made out. It seemed then to show an actual change in width, coincident with alteration of visibility, but this, too, could not be predicated with certainty. It was also surmisable that the westernmost line was the one from which the development proceeded. In 1905 much more was made out about it, training in the subject and increased proximity of the planet contributing to the result. It now became clear to me that the canal did develop from the western side, for the western edge made a dark line of definite boundary from which shading proceeded to the eastern side, where it faded almost imperceptibly off with no defined line to mark its limit. That this shading gradually darkened was evident, but that when it could be seen at all, it extended to the extreme limit of the eventual double, restricted the character, if not the fact, of an actual widening. At this opposition, too, the canal passed through its period of minimum visibility, and was then seen, whether it could be caught, as a confused swathe of full width. In the case of this canal, then, a widening in the sense of a bodily separation of two lines seems inadmissible. On the other hand, the gradual darkening of the swathe, and especially the advance of the darkening from the western side, points to an interesting process there taking place. At the opposite end of the series stands the Jihoon. As the Ganges is the widest of the instantly impressive doubles, so the Jihoon is the narrowest the eye has so far been able to make out. Only 2/5 of the width of the Ganges pair, this slender double is very nearly at the limit of resolvability. So well proportioned are its lines to the space between them, however, that in ease of recognition it surpasses many wider pairs. In form, too, it is distinctive, turning by a graceful curve the trend of the Margaritifer sinus into the Lucus Isthmianus. With its fundamental branch, the northern of the two, it joins what is evidently the main line of the Proternillus, also the northern one, to the Margaritifer sinus's tip. It differs from the Ganges in some other important particulars besides width. In its case, no band of shading distinguishes it at any time. It has always been two lines, whenever it has been seen other than as a single penciling, the only confusion about it being evidently our own atmosphere's affair. These two lines, furthermore, have showed within the areas of observation always the same distance apart, so that not only no change of intercommunication between the lines, but no change in their places apparently occurs. Between these extremes in width, 200 miles more or less for the Ganges, and 75 miles for the Jihoon, the distance parting the pairs of most of the double canals lies. From 3 degrees to 3.2 degrees on the planet may be taken as that of the average. The degrees denoting latitudinal ones on the surface of Mars, the length of which is equal to 37 of our English statute miles. Most of the canals conform apparently to the type of the Jihoon rather than that of the Ganges. Careful consideration of them fails to find any increase or decrease of distance between the pairs of the same canal at different times, which cannot be referred to errors inevitable to observation of such minute detail. In short, the double is made by the addition of a second line in a particular position, and not by a growth out of it of a line coincident to begin with the first. I have said that the average width between the two lines of the doubles was about 3 degrees. It must not be supposed that this average width denotes anything more than an average, or, in other words, that it denotes anything in the nature of a norm. The remark is important in view of a suggestion which I have heard made that we have here a system based on fundamental Martian units, in which, or in multiples of which, the dimensions of the canals are implicitly expressed. Such, however, does not seem to be the case. In some instances, indeed, we have certain evidence to the contrary, and that the width of the double is conditioned solely by antecedent place. The Physon and Euphrates offer a case in point. These two important arteries in duplicative leave, as we saw, from 2 carats in the Mare Icarium, the Portus Sigae, held in common tenancy by both. Each pair then proceeds down the disc inclined at its own particular angle to the meridian, in order to reach, by a great circle course, a certain spot. The Ciboas Lucus in one case, the Lucae Isthmianae in the other. As one of these angles is 35 degrees, while the other is only 3, they must, from the circumstances of their setting out, have not only different widths, but widths determinedly different in advance, since each is, roughly speaking, foreshortened by the degree of divergence from the meridian. The one, therefore, must be about 4 degrees to the other's something less than 3.5. That is what they actually are, as determined by measurement from observation. That the calculated value agrees with that found from observation helps certify to a community of starting points, but it completely does away with comprehensive design in the question of their widths, for if the one were so settled, the other could not be. Indeed, the next example seems to deny it to both. This example occurs, too, not far away from the scene of the first, in the twin bays of the Sabaeus Sinus, from which depart mutatis mutandis, the double Hiddekel and the two Gihon. These twin gulfs bear so little imprint of being other than natural formations that they have been universally and very likely quite rightly taken for such ever since Dawes discovered them in 1859, long before things like canals were dreamed of. It is strange that when the Hiddekel and Gihon were found by me to be double in 1897, with a branch of both leading from each bay, the connection between the sceptically scouted doubles and the thoroughly believed-in bays should have been apparent. For to link a ghost to materiality, if it does not discredit the materiality, serves to substantialize the ghost. Furthermore, it shows that in this case neither the one double nor the other can have had its width engineered on any preconceived scale, unless the twin bays be themselves so accounted for, so that it seems useless to seek for cryptic standards in the canals, or to think to find them a measure of value from the fact of their being a medium of exchange. A third instance of the same thing in the case of the Ganges and the Jumuna was proved at the last opposition, after having long been suspected without my being able to make sure of it. These instances, taken in connection with the wide range of values in the widths presented by different canals, serve to show that the distance between the twin lines is an individual characteristic of the particular canal, and further to point to its cause, in some cases certainly, and possibly in all, as topographical. The duplicate line makes a convenience of a neighbour, and suits its distance from its fellow to friendly feasibility. To cut a canal to conform to the country seems logical, if not obligatory, and quite in keeping with the nomenclature of the subject, but here the starting point appears to be the only thing considered, the canal once safely launched being left to shift, or rather not shift, for itself. 4. Topography thus introduced to our notice for its effect on the breadth of the doubles proves upon inspection to be of extended application to the whole subject. Examined for position, these canals turned out to have something to say for themselves, bearing on the question of their origin and office. With regard to position, probably the first query to suggest itself to an investigator to ask is of the direction in which they run. Is there a preponderance manifest in them for one direction over another? Do they show an inclination to the vertical, to the horizontal, or to some tilt between? To answer this, we may box the compass, and taking the 4 cardinal points with the 12 next most important points, between for sectional division, segregate the doubles according to their individual tread. As we have no means of determining in which sense any direction is to be taken, if indeed it is not to be taken alternately in each, we get 8 compartments, into one or the other of which all the doubles must fall. This they do in the following manner. South and North Lystrigon, Fretum Anion, Ethiops, Amenethes, Titan, Dis, Is, 7. South-southeast and north-northwest, Gihon, Ganges, Tithonius, Euphrates, Adamas, 5. Southeast and northwest, Eunostos, Triton, Tartarus, Narmalka, 4. East-southeast and west-northwest, Astarborus, Typhon, Pierius, 3. East and west, Nar, Protonillus, Propontis, Nectar, Cocytus, Chaos 6. East-northeast and west-southwest, Deuteronilus, Caliro, Cerberus north, Cerberus south, Psittacus, Erebus 6. Northeast and southwest, Jehun, Nolocaris 1 and 2, Avernus, Nepenthes, Gygus, Alander, Polyphemus, Gelbes, Marsyas, Pyramus, Niloceras 1, Asopus 12. North-northeast and south-southwest, Jamuna, Phison, Hyblaeus, Cyclops, Lethes, Thoth, Vexillum, Hiddecal 8. Total 51. No conclusively marked preponderance for one direction over another manifests itself by this partitionment. Nevertheless, a certain trend to the east of north as against the west of north is discernible. More than twice as many doubles run northeast and southwest, or within 45 degrees of this, as do similarly northwest and southeast, there being 12 of the latter and 26 of the former. That this seems to mean something, the nearly equal pairing of quadrantal points goes to show. Thus, north and south and east and west, inclined canals number 7 plus 6 equals 13. North-northeast and south-southwest, and east-southeast and west-northwest, inclined canals number 8 plus 3 equals 11. Northeast and southwest and southeast and northwest, inclined canals number 12 plus 4 equals 16. East-northeast and west-southwest, and north-northwest and south-southeast, inclined canals number 6 plus 5 equals 11. Total 51. A fairly equable division in direction. A trend to the westward could be given a particle descending from the north to the equator by the planet's rotation, thus turning it southwesterly, and one to the west to a particle travelling equatorwards from the south, turning it northwesterly. As the doubles lie in the northern hemisphere, either in whole or part, to the extent of 93%, this might account for the preponderating tilt to the east of north and the west of south exhibited by them. It would correspond with the lines of flow. To see whether this be so, we will take only those double canals that lie exclusively in the northern and southern hemispheres respectively, and note those in the former that trend to the west of south as against those that run to the east of it, and vice versa in the southern. In the northern, the proportion of the westerly to the easterly ones is 17:4, in the southern 1:0 the other way. Of those whose course is common to both hemispheres, we find for the ratio of the southwesterly to the southeasterly 8:7, but the proportion of the course of these canals in the two hemispheres is on the side of this same ratio. From their direction, we now pass to consideration of their distribution in longitude. It appears that some meridians are more favoured than others. The hemisphere which has the Syrtis Major for centre is more prolific in them than its antipodes. From longitude 80 degrees to 200 degrees there are 10 doubles, from 200 degrees to 320 degrees 24, and from 320 degrees to 80 degrees 17, or roughly in the proportion of 2, 5, and 3. That this distribution means anything by itself is doubtful. It is much more likely to be a general topographical consequence of their distribution in another direction, which proves to be highly significant, and which we shall now expose, that of latitude. If we separate the surface into zones, each 10 degrees wide, and count the doubles found traversing in whole or part of several zones, we find the following arrangement. Double canals of Mars arranged according to latitude. Between 30 degrees south and 20 degrees south, Tithonius, Nectar, Lystragon, Jamuna, Ganges, Gygus, Lystragon. At opposition of 1903 alone, 2. At all oppositions so far observed at Flagstaff, 3. Between 20 degrees south and 10 degrees south, Cyclops, Titan, Tartarus, Polyphemus, Tithonius, 1903, 7. All, 9. Between 10 degrees south and 0 degrees, Jamuna, Ganges, Gygus, Lystragon, Cyclops, Cerberus south, Ethiops, Lethes, Amenthes, Triton, Phison, Euphrates, Titan, Tartarus, Adamus, Typhon, Vexillum, Asopus, Naamalka, Polyphemus, 1903, 15. All, 20. Between 0 and 10 degrees north, Gihon, Jehun, Jamuna, Ganges, Gygus, Lystragon, Cerberus north, Cyclops, Cerberus south, Euonstos, Aethiops, Lethes, Amenthes, Triton, Nepenthes, Phison, Euphrates, Cytacus, Hiddekel, Tartarus, Adamas, Asopus, Typhon, Vexillum, Cocytus, Is, Avernus north, Naamalka, Polyphemus, 1903, 21. All, 29. Between 10 degrees north and 20 degrees north, Gihon, Jehun, Jamuna, Nilocaris 1 and 2, Nilocaris 1, Ganges, Gygus, Euonstos, Ethiops, Lethes, Amenthes, Thoth, Astaboras, Phison, Cytacus, Euphrates, Hiddekel, Adamas, Asopus, Galbes, Avernus north, Erebus, Naamalka, Vexillum, Is, Dis, 1903, 18. All, 26. Between 20 degrees north and 30 degrees north, Gihon, Jehun, Jamuna, Nilocaris 1 and 2, Nilocaris 1, Alander, Hyblaeus, Lethes, Amenthes, Thoth, Cytacus, Astaboras, Vexillum, Phison, Euphrates, Hiddekel, Adamas, Euonstos, Ethiops, Galbes, Avernus north, Naamalka, Is, 1903, 17. All, 23. Between 30 degrees north and 40 degrees north, Deuteronilus, Alander, Na, Marcius, Fretium Anian, Amenthes, Thoth, Vexillum, Phison, Euphrates, Hiddekel, Adamas, Euonstos, Jehun, Gihon, Nilocaris 1, Chaos, Galbes, Ethiops, Naamalka, 1903, 12. All, 20. Between 40 degrees north and 50 degrees north, Fretium Anian, Pyramus, Protonillus, Propontis, 1903, 3. All, 4. Between 50 degrees north and 60 degrees north, Caliro, Fretium Anian, Pierus, 1903, 3. All, 3. Between 60 degrees north and 63 degrees north, Pierius, Caliro, 1903, 2. All, 2. From this tabulating of them, it is apparent that the doubles are practically confined to the zones within 40 degrees of the equator. Only 7% of them straggle farther north than this, while above 63 degrees north latitude and 35 south latitude there are none. Such a distribution is not in proportion to the areas of the zones, which, though diminishing toward the poles, do so at no such rate. The surface included between the equator and 40 degrees of latitude is 65% of the hemisphere, whereas the fraction of the number of doubles found there is 93%. The doubles are, then, an equatorial feature of the planet, confined to the tropic and temperate belts. To perceive the tropical character of the doubles in another way, we have but to consider the zonal distribution of the single canals. Unlike the former, the latter do not thin out as one advances toward the poles, since in the Arctic region single canals bemesh the surface as meticulously as elsewhere. It is only that they there replace the doubles, or, not to put the cart before the horse, it is the doubles that in part replace the singles in the tropics. And that this arrangement has something physical behind it by way of cause is curiously shown by two canals, the Arnon and the Caisson, which are neither of the one kind nor yet the other, but a cross between the two. For the Arnon and the Caisson are convergent doubles, the two lines of the Caisson leaving a common point at the edge of the polar cap, and separating as they travel south, while the two Arnon take up and continue the divergence, connecting at last with the parallel pair of the Euphrates. These canals thus make transition between the true doubles and the true singles, and may be looked upon as endowed with the potentialities of both. From their association with the double Euphrates, it is clear that the transition between the two forms is not only formal but physical, and that the stopping of the dual condition at the 40th parallel is not the outcome of chance. It may occur to the thoughtful that the doubles appear confined to the more tropical portions of the planet because of a better presentation of these zones, the reader supposing the planet to be seen axised perpendicularly to the plane of sight, as geographies represent the Earth's globe. The supposition, however, is erroneous. We sometimes see the planet so, but more often not. Such is the tilt of the Martian axis to the plane of the Martian ecliptic, that the different zones are rarely seen on an even keel, so to speak, their aspect shifting totally from one opposition to another. What shows in mid-disk on one occasion may be 48 degrees removed from it at another, a distance amounting to 3/4 of the way from apparent equator to apparent pole. Thus the double canals are for some intrinsic region equatorial features of the planet as opposed to polar ones, and this is not simply because of greater space there. Duality is a result of conditions intrinsic to the several localities. What the cause may be is related to the character of the things themselves, which we shall later consider. For the moment, we may note that the fact discloses quietly of the diplopic theory of their manufacture. For diplopic doubles to show such respect for the equator would betoken a courtesy in them to be commended of Sidney Smith. But this is not their only geographic bias. In addition to not being partial to the poles, the double canals show a certain exclusiveness towards the dark areas generally. Not only do they avoid the Arctic and Antarctic zones entirely, but they largely shun the blue-green regions. In these but two suspicions of doubles occur, in the Aeonian sinus, although single canals there are as numerous as anywhere else on the planet. Nevertheless, although they avoid running through them, they run from them in a manner that is marked. Proceeding from the great diaphragm are no less than 28 out of the 53 doubles. Connecting directly with these are 17 more, while the remaining 8 are also associated through the intermediarism of dark areas, like the Solis Lacus and the Trivium. In like relation to dark regions, they are limited on the north by the Mare Acidalium, the Propontis, the Wedge of Cassius, and their interconnecting bands, the Pierius, Caliro, Helicon. In this manner do they form a broad girdle round the planet's waist, leaving the polar extremities bare. End of section 20.